This is our topic 2 review. Michelle uses 6 1/9 inches of wire to make a necklace and 3 1/3 inches of wire to make a bracelet. How many necklace and bracelet sets can she make if she uses 28 1/3 inches of wire in all? Take a second to copy down the question. The first thing I'm going to determine is what my variable stands for. My variable in this problem is x. X equals the number of sets that she can make. Since my necklaces are 6 1/9, it'd be 6 1/9 times the number of sets plus the 3 1/3 times the number of sets is going to be equal to the total amount that she uses, which is 28 1/3. If I turn 1/9 into a decimal, I get a repeating decimal. So I cannot use that in my problem. So I'm going to turn all of my fractions into improper fractions. 6 times 9 is 54, and then add 1, I have 55 over 9. And the x can go in my numerator. Plus 3 times 3 is 9, plus 1 is 10 over 3, and the x again can go in my numerator. 28 times 3 is 84, and then add 1, I have 85 over 3. Now I need all of my denominators to be the same. So my denominators are 9, 3, and 3. The number I can turn all of them into is a 9. I can keep this 55x over 9. 10x over 3, I can multiply by 3 over 3. 10x times 3 is 30x. 3 times 3 is 9. And then I can do the same thing with my other fraction. 85 over 3, I can multiply by 3 over 3. 85 times 3 is equal to 255 over 9. Now, since all of my denominators are the same, I can just get rid of them. I would have 55x plus 30x equals 255. 55 plus 30 is equal to 85x equals 255. Divide both sides by 85. 255 divided by 85 is 3. X equals 3. So that means that Michelle can make 3 sets of necklaces and bracelets. The second problem. Solve the following equation. 75 minus 3.5y minus 4y equals 4y plus 6. Take a second to copy down the question. First thing I'm going to do is I'm going to simplify my left-hand side. I notice my like terms are my negative 3.5y and negative 4y. When I combine those, I get negative 7.5y equals 4y plus 6. There are no more like terms on my left-hand side, so I look at my right side. There are no like terms on my right side. Now, I'm going to move all my variables to one side and my constants to the other. I'm going to add 7.5y and 7.5y to both sides. These cancel out, and with left with 75 equals 4y plus 7.5y is equal to 11.5y plus 6. Subtract 6 from both sides. 75 minus 6 is equal to 69. 69 equals 11.5y. 6 minus 6 cancels out. Now I can divide both sides by 11.5. 69 divided by 11.5 is 6. So I have 6 equals y. And that's the solution to this equation. Next problem. Solve the following equation. 5 parentheses 4x minus 1.5x plus 12 equals 4x minus 2. Take a second to copy down the question. I'm going to start by getting rid of the parentheses by using the distributive property. 5 times 4x is 20x. 5 times negative 1.5 is negative 7.5x. I bring down the rest. Plus 12 equals 4x minus 2. Again, I'm going to combine my like terms. 20x minus 7.5x is 12.5x plus 12 equals 4x minus 2. Now I combined all my like terms on the left. There's nothing to simplify on my right, so I'm going to move all my variables to one side and my constants to the other. I'm going to subtract 4x from each side. 12.5x minus 4x is 8.5x plus 12. 4x minus 4x cancels out, equals negative 2. I'm going to subtract 12 on both sides. I'm left with 8.5x. 12 minus 12 cancels out, equals negative 14. I divide both sides by 8.5. Negative 14 divided by 8.5 gives me negative 1.647. There are other numbers after that decimal, but I'm just going to round it and leave it as that. So x equals negative 1.647. Does the following equation have one solution, no solution, or infinite solutions? Take a second to copy down the question. I'm going to start by using my distributive property. Negative 3 times x is negative 3x. Negative 3 times negative 14 is positive 42. Plus 9x equals 6x plus 42. I'm going to combine my like terms on the left-hand side. Negative 3x plus 9x is 6x. This 42 just comes down, equals 6x plus 42. When you get to this step and you notice that the left-hand side and the right-hand side are exactly the same, we know in that case, that means we're going to have infinite solutions. If I were to continue to solve it, 6x plus 42 equals 6x plus 42, I would subtract 6x from each side. And when I subtract 6x from each side, 6x minus 6x cancels out. And I'm left with 42 equals 42. And since they are equal, I have infinite solutions. Compare the proportional relationships. Which represents the greatest price per pound for walnuts? We have three options. Option A is a 1.5 pound bag of walnuts that costs $12.99. Option B is given to us in the table, and option C is given to us in a graph. Take a second to copy down all three options. when we are looking for the price per pound in a fractions means that we're going to have the price over the pound. So for option A, the price is $12.99 over the 1.5 pounds. $12.99 divided by 1.5 is 8.66. So option A costs 8.66 per pound. For option B, we can do the same thing. I can pick any option. I'm just going to pick the first one. $2.80 divided by the 0.2 pounds. So $2.80 divided by 0.2 is equal to 14. So option B is $14 per pound. So we know at this point that option A is cheaper. So now I have to check option C. Option C, I have to look at my graph. I want to pick a point that's right on my grid. So right here, that's my point because it falls perfectly on an x-axis and on the y-axis. This point is 1, 10. That means that the price is $10 and the pounds is 1 pound. 10 divided by 10 divided by 1 is 10. So now I have my three costs. Option A is $8.66 per pound. Option B is $14 per pound. And option C is $10 per pound. The problem wants to know what is the greatest price per pound. The greatest price is option B because that is the highest number. And the last question. Write an equation of the following graph in slope-intercept form. Take a second to copy down the problem and a quick sketch of the graph. Slope-intercept form is always going to be the same thing. Y equals mx plus b. The m is the slope and the b is the y-intercept. In a graph, the easiest one to find is the y-intercept. The y-intercept is where your graph crosses or touches the y-axis. That's right at this point. So I know I'm going to have y equals x minus 3, whatever my slope is, and then minus 3 for my y-intercept, because that's what my y-intercept is. Now to find the slope, I'm going to pick another point. Right here, this second point falls directly on my grid. So I'm going to use both of those points. The slope is the rise over the run. Or the rise is how the x changes over how the y changes over how the x changes. So it's the change in y over the change in x. So to get from this point to this point, I have to go up 1, so that's a positive 1, and then I have to go over 1, 2, so my slope is 1 over 2. So my equation is 1 over 2x minus 3. If we weren't given this in a graph and we had the points, our slope formula is y2 minus y1 over x2 minus x1. So we could also use this formula to find our slope of any 2 points.